Let's talk about the trapezoidal rule, which is our first idea how we can do the integration. What is the idea? We have a function f of x, which is the integrand, and we want to integrate on the interval a, b. This is a and this is b. And then we split this interval into some parts. Each interval has the same length. The first point is a, the last point is b. And then we evaluate the integrand, which is f of x, on the integration interval. And then we get values. For example, this is the value f of a, this is the value f of b, and in between maybe like that. So we have function values, and then we assume straight lines, a linear function in between. And if we assume that function instead of the original function, but then we can take the area under the straight lines. If you have negative values of f, then nothing changes at all. So let's keep this sketch simple. Okay, so this is our idea. And what does that mean? I named that f of x. I should have better named it y of x, but it doesn't matter so much. So what is that idea? We first have to choose how many parts do we take. Okay, if we did that, that means a, b. So in this case we have chosen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here we have chosen n to be 11. And then we set this point to be x0, this point x1, x2, x3, x4. And then we have these points. Now we evaluate y of x, and then we get y value. Like that. And these are the y value. So this value is the y0 value, y1 value, y2 value, y3 value, and so on. And if we assume a straight lines and we want to take the area under this straight line, what is the formula for the area? If this is xk minus 1 and this is xk, then we have these two function values. And what is the area here? We can take the mean value of these two. So this is the value exactly in between of these two. And then we can take that area. This triangle is also here. So this rectangle has the same area as this trapezoidal area. And so we can write this is h. Here we have our h. And then this area is h, this length, times that length, which is the mean value. So the mean value is the sum divided by 2. And so we have the area of one triangle, or here of one triangle, and of these, and now we have to add these areas, and then we get the sum. We start at 1 and sum at n. First trapezoidal, second, third, and so on. And now we have h times this. It starts with y0 and y1, and then it steps 1 to the right. And then, what does that mean? If we don't write with the sum symbol, we can write, it starts with y0 plus y1 halved plus then one step to the right, 1 y1 plus y2 halved plus and so on plus yn minus 1 plus yn halved. And now we can write y0 halved plus y1 halved plus y1 halved, which is y1, plus y2 halved plus y2 halved, which is y2, and so it continues yn minus 1 halved, and there's another yn minus 1 halved, so we have yn minus 1 plus yn halved. So each of these yks are 2 times in that sum apart from y0 and yn, and this is the reason why we have here y1, y2 and so on, but only y0 halved and yn halved. Okay, and this is quite interesting. We can interpret that in another way. We can say if these are the midpoints, then we can interpret this sum like that. And we take these points times h, but with the border here, a and b, we take only half the rectangle. Okay, this understanding is not very important, but if you're a mathematician, that's interesting, and so I did that remark. But this is not the important sketch. This is the important sketch. What do we need last? We need an example. Okay, not so much space, but maybe we are interested in the integral of e to the minus x integrated on the interval 0 to 2. Let's choose an n. And what shall we choose? Whichever natural number you want. Maybe you are choosing 6. Okay, then we have this h. This is 2 minus 0, the length of the interval, divided by 6. We divide that into 6 parts, and so this is the length of each part if the total length is 2. And this is 2 divided by 6, 1 divided by 3, 0.333. Okay, now we take these points. We have an x0, x1, and the first one is 0, the last one is 2, and in between we go with this step width. So, and now we evaluate that function at these points, and then we get e to the minus 0, e to the 0, which is 1. This is y0. Then e to the minus 0.333. Ask your electronic calculator and he will tell you 0.7165. And so you get this value, 0.5134. E to the minus 1, 1 divided by e, 0.3679, and so on. y1, y2, and so on. And now we approximate that integral by h, which is 0.3, times the first value halved. These values multiplied by 1, so 0. Plus the last value halved again. And now again ask your calculator, your electronic calculator, and you will get an answer, and this is 8727. The correct value in this case, it's not hard to do that. The antiderivative of e to the minus x is minus e to the minus x, and then you can integrate exactly without any problem, and the correct value is 8647 instead of 8727. Okay, if you want to get a better result, what can you do? You can choose n to be, let's say, 30, and then you will get a better result. But this is the very simple idea of the trapezoidal rule. Very easy to understand, very easy to get this formula, and very easy to apply. In the next videos, I will give you some more information to the trapezoidal rule, and then we will develop new ideas, but this is the basis. You should understand that, and if you understood that, then you will easily understand also the idea behind Simpson rule and so on. So we are done. This was our video for the trapezoidal rule.